Hello, I am the author of this suspension calculation spreadsheet tool, which started out as quite simple but ended up getting really difficult to use if you don't know what you're doing. So I thought I'd make this fairly quick video to show you how to go through the process. And this is more or less a simplification of everything you can do here, but I will go over the main points. So, what does it do? It will help you, or at least try to help you, calculate the natural balance of your suspension with the springs, and you can help you adjust that balance if you want, for example, more or less understeer or oversteer. And in addition to that, it will also help you adjust your damper settings to suit your springs. So right from the get-go, we'll take a quick look in the springs and a quick look in the dampers. Springs are the things that keep your car from bottoming out. Those are actually things that keep it up overall. The dampers are the things that control the springs so they don't just bounce up and down all the time. And the basics are that the heavier the car, the stiffer the springs need to be to provide the same level of perceived stiffness. And naturally, the lighter the car is, the softer the springs can be and still feel quite stiff. And if you change the springs to stiffer ones, you will need to damp them more, and if you change the springs to softer ones, you will need to damp them less. So every time you change the springs, you also must change the dampers, unless the change is really small. So a quick look over the balance of the thing. There are two main aims when you are setting up the balance. You will either generally want to put a higher rear bias or a higher front bias. Higher rear bias is common in street cars, where it helps with comfort, and it is not necessarily the most optimal setting for track use, because stiffer rear end can cause oversteer. But for comfort reasons, it is the most common one in street cars. Stiffer front, on the other hand, can cause understeer and is more uncomfortable for passengers. But on the other hand, in racing cars, it also means that you can have a stiff front that reacts quickly to steering input and keeps the front splitter at the right height, and the soft rear will help the rear tires maintain traction when you're accelerating hard. So you can have a nippy front end and lots of rear grip with that setup, but at the cost of comfort. So without further ado, let's do two examples of both. So for example, let's pick the Roof RGT8 as our street car, and we shall pick it. First of all, you go to this select car bit here, you click on it, it will show you this drop down button. Click on that and select the RGT8 from the drop down menu. That will load up all these bits in gray here, so it will automatically load up all the weights and weight distributions and unsprung weights and yada yada yada. Next, you go here and select this wheel rate front, spring rate. You select it, and again the drop down menu. The first value here is the default value that was in effect when I last updated the spreadsheet, and everything below it after the empty space are the settings available to the car, or at least they were when I last saved it. and don't worry, you don't actually have to use any of these. You can also write anything you want into the spring rate box if the settings happen to change. So let's pick the default setting at the front, and then we shall go to the wheel rate rear, spring rate, same thing again. Let's pick the default. Okay, so what we are doing here is we're doing a streetcar, and that means we want a higher rear frequency higher than the front one is, and we can check here for some examples of various streetcars and a couple of racing cars, and we can see that the streetcars, especially the older ones, were generally quite low down on the list when it comes to front frequency, and the relationship between the frequency and the stiffness is that the higher the frequency is, the stiffer your suspension is. So these would be soft suspensions, whereas this 2.37 Hertz here would be a stiff suspension. So I don't think we are going to go quite that soft, but let's pick something like 2 Hertz as our... Oh, well, let's actually check what our options are. So let's pick the softest springs here. That's 27 newtons per millimeter, which gives us 1.6 Hertz. So that's still it's a bit stiffer than Lotus LEs from some year or another. The LEs is more of a like a track day car or something more than a comfortable cruiser, so it actually doesn't have that much higher rear bias. But we will want to put something like 20% higher. So we have picked our front spring, and we can see our front frequency. So we shall take a look at these rear springs, Cheston Street, higher rear. We want 20% higher, which would be 1.92 Hertz, which would be 82.9 newtons per millimeter. So let's see if we can get close to that. 82.9, so 83, that's 86 is the closest we can get. So we could either go a bit above at 22% higher at the rear, or a bit below with the softer springs at 16% at the rear. Because the RGT8 is rear engined, I'd rather have a bit more grip at the rear, so I'm only going to use 16% in this case. So yeah, let's go with this. After that, it calculates the damping rates, so we can take a look at the damping next. So springs, you are fairly free to choose however you want. Just keep in mind that the 2 Hertz limit is fairly close to where you start getting from street cars to racing cars. So street cars tend to be under 2 Hertz, and racing cars like autocross cars and GT4 cars can be in the somewhere in the 2 to 3.5 Hertz range. So something like that. After that, you can we have to pick our damping. So the way I pick my damper settings is by using something called critical damping, and it is this thing here. Basically, what critical damping basically means is that it's not underdamped and it's not overdamped. Underdamped is when the dampers are actually soft enough that they allow the springs to vibrate up and down. So basically, if you hit a bump, the car will keep wobbling about for a while until it settles down. Overdamped, on the other hand, or supercritical damping, is when the dampers are so stiff that they are actually slowing the car down and the suspension cannot react as quickly as would be possible. So it will take a longer time after a bump before the car is settled down. There are some uses for this in extreme cases, but not really all that much in street cars. Critically damped would be when everything happens as quickly as possible, so you hit a bump, the wheel goes in, the wheel comes out, and then it's there. It doesn't bounce up and down at all more than once, and it takes the minimum amount of time to do it. So that's basically what critical damping means. Critical damping isn't actually the optimum setting even for a racing car usually, if of course everything depends. Generally you would want to use something like 70 to 80% of critical damping, or perhaps a bit below 70%. So this is where the bottom part of my spreadsheet comes into play. What we have here is some calculation stuff which at the end gives us the front and rear critical damping with the motion ratio included. So these are the damper settings you would use in game to get fully critical damping. Then we get to the suggestions, and like I said, usually you would go for a racing car something like 70 to 80% for rebound at least, and according to at least one guide you would use something like 50 to 70% of the rebound damping value for slow bump damping. So in this case I have used the 80% critical rebound setting, which is these two numbers here as the calculation point for these values. So basically you just go over here and pick numbers. The upper row is the front setting and all the suggestions, and the bottom row is the rear setting. So if you wanted a pretty stiff racing car sort of setup, you would put this value as the front slow rebound, this value as the front slow bump, this value as the rear slow rebound, and this value as the rear slow bump. Fast dampers aren't that important usually, but I tend to use these values here. So this would be the front, again the upper row is the front values and the bottom row is the rear values. So this would be the front slow rebound, the front fast rebound. This would be the front fast bump, this would be the rear fast rebound, and this would be the rear fast bump. So basically just pick these values for your dampers and you're basically done. You can you might actually want to go a little bit stiffer with this setting, and perhaps with these two settings and these two settings as well on some cars, due to the way Project Cars is working. But in this case I want to do a street car, so I will take this box titled Lamborghini Gallardo. These are based on some snooping around and should represent what the Lamborghini Gallardo Balboni uses. So these would be quite stiff rates for a street legal sports car. I'm not sure if they're accurate, but they do seem to fit the general region of what you'd want in a sports car, and are noticeably stiffer than your average everyday car. In this case you would just go with these two values as the front and rear slow rebound, these two as the front and rear slow bump, these two as the front and rear fast rebound, and these two as the front and rear fast bump settings. And notice that none of these actually take into consideration if you can use such values in the game, just that these are the suggestions that you would use. So simple as that. Pick a car, pick some springs, and pick your values from somewhere here. Then let's try to make a racing car. Let's take the set for GT3 and try to have it. Let's make it have a 20% higher front frequency, for example. So yeah, let's scroll to BMW set for GT3. Let's pick the defaults. So here, and immediately we can see that the car is quite a bit stiffer at the front than the roof was. It's 3.3 Hertz. This seems to be the sweet zone for GT3 cars. So somewhere around 3.3 to 4 or something like that seems to be quite common in the case's default settings. But the rear is quite soft at 2 and a bit Hertz, so it's almost street car soft, and indeed we can see that the 60% we have a 60% higher front spring frequency, or a natural frequency. So in this case, since I wanted to try a less sort of understeery setup, I'm gonna try this 20% higher front frequency. So these are all suggestions for the rear springs, by the way. I usually do my setup so that I adjust the front to whatever frequency I want it to be, depending on whether it's a racing car or a street car, and after that I adjust the rear springs to match whatever balance I'm looking for. So let's take 20%. That's here, and it's 2.76 Hertz and would be 178 Newton meters. So let's see what we have. We actually don't have anything above 140. Well, that's unfortunate. That basically means we're going to have to soften up the front. 35%. Well, what can you do? 181. Okay, I need to go way down to 160 and 140. So basically this would be pretty soft setup for a GT3 car. Perhaps it's a really bumpy track at slow speeds, and you can't rely on the aerodynamics to give you enough grip to turn in, so you want a bit more oversteer balance in the car. Sounds reasonable. So with this, I just pick the springs like this, and once again, here are the critical rates as they would be in game, and suggestions. So for a stiff damper setup, I would put this as the front slow rebound, this as the rear slow rebound, front low bump, and rear low bump, or slow bump rather, and the fast rates would come from here or something like that. Of course, this is just a baseline. You will adjust it to your taste later. So it really is that simple. You just pick a car, you pick some springs, and then pick the values from the suggestions. And yeah, on top of that, I'm gonna quickly go through this roll bias thing. This is basically the sort of measurement of how much either end of the car will resist leaning to the sides. So let's put these to the default values again. So again, the topmost value is the default value in the setup and in the default setup. So yeah, with this, this basically works in a similar way to the front and rear bias, in that higher front bias is this actually means 63%, not 0.63%. But yeah, basically it means that the higher this number is, the more understeery the car will be, and the lower it is, the more oversteery it will be. In racing cars, you usually get around under and oversteer quite easily with the alignments and the great tires and stuff like that. But in street cars, this can be set to closer to like 50-50 or 55 or something like that, just so you don't get too much understeer. In racing cars, you tend to have quite a bit of roll resistance at the front, so that you get really quick turn-in response when you turn the wheel. So again, you can see how this changes the balance. So for example, if instead of 56 we pick 30, it goes down to 58 here. So this means the balance moved backwards and the car will be more oversteery as a result. The main use for this would be to, if the car is leaning too much, you like the balance but the car leans too much, so you want to go stiffer but have the same balance. So you could go like this. So we want a 63% balance, but we want to use stiffer anti-roll bars. So stiffer than 56, let's take for example 70. Now we have more than 63 here, we have 65, so we need to adjust this from 25 to, let's 35, that's 62, it's a little bit too much actually, so 33, okay, so 30. So basically what this means is that we get less roll than we got before, which actually might be a good thing because the suspension is a lot softer due to the springs here, but we have the same balance as we did before. So yeah, that's basically what that does. So I don't think there's not too much more for me to talk about right now. So the important things on how to use this: pick a car, pick springs, use these to get some suggestions for balance settings. Higher front frequency in this box will cause understeer, a higher rear frequency will cause oversteer, and once you've got your springs, use these and these. Yeah, use these for the slow rebound settings, these for the slow bump settings, these for the fast rebound, and these for the fast bump settings. Easy as that. And then you can also calculate the roll bias here. So hopefully you found this even a bit informative and can use the tool better. Next time I will be showing you a bit of work in progress type of stuff, so see you again. Bye!